All right, let's learn a little bit about Newton's second law. We learned yesterday that force is equal to mass times acceleration. Usually we're going to use this with force being force net, meaning the net force on an object. And to clarify, just to reinforce, F net is the net force, m is mass, and a is acceleration. So let's do an example to see how we would use this. Let's say we have an elevator and it's moving upward, but it's slowing down at a rate of 2 meters per second squared. First question we want to ask is this thing accelerating? Thing being the elevator. Well, it's slowing down, which means it's not at a constant speed, so yes, it is accelerating. The next thing we want to do is draw a free body diagram. But wait a second, we need to know which way it's accelerating to be able to draw this correctly. The elevator is accelerating downward because it is moving upward but slowing down, so it's speeding up the opposite direction. So moving up but accelerating downward means it's slowing down. So when we draw the free body diagram, we know that there has to be a bigger force going downward than there is going up, right? Because if it's accelerating downward, the net force has to be downward. So there's two forces on an elevator, force of gravity, always, and then the force of tension. So we got force of gravity going down and force of tension going up. Force of gravity has to be bigger because it is accelerating downwards. Excuse me. Okay. Step 3, use our equation. So today we're just going to be doing the setup. We're not actually going to be calculating. We just want to make sure we have these equations set properly. So F net equals ma. What does F net mean? Basically, it means the winners minus the losers is equal to mass times acceleration. In this case, which force is winning? Well, it's the gravity force, right? That's the bigger one. So we have Fg minus Ft, force of tension, is equal to mass times acceleration. And that right there is all we have to do to set up the problem. So first, is it accelerating? Yes. Which way is it accelerating? Draw your free body diagram, make sure that the forces are drawn to scale or relative to scale so that the bigger one is in the direction of acceleration. And then plug in your values for F net, doing winners minus losers is equal to mass times acceleration. So let's do one more problem. So here we have a car. This car is driving to the right and it is speeding up. Speeding up. Okay. So, first question, is it accelerating? Well, is it at rest? No. Is it moving at a constant speed? No. So it must be accelerating. Yes, it is accelerating, and it's accelerating to the right. Why? Because we're moving to the right and speeding up to the right. Our movement and our acceleration are in the same direction, so we are accelerating in that direction. Number 2, draw the free body diagram. So we know we've got 4 forces, or let's start with 2. We've got 2 forces on this thing. Applied force, right? We're stepping on the gas. That's making us move forward. And we've got friction force pulling us back. We know that it's moving to the right, accelerating to the right. So our applied force to the right must be bigger than our friction force. But we can't forget the other forces acting on this object. Force of gravity and the normal force. These two are going to be equal because it is not accelerating vertically. So Fn is equal to Fg, same size arrows, and then Fa to the right has to be bigger than F of friction, force of friction, to the left because it is accelerating to the right. Step 3, we have our equation. So in this case, winners minus losers is our applied force minus our friction force. We set that equal to ma, and that is our equation. When we have a problem with numbers, we'll be able to plug this in and solve for an unknown force or an unknown mass or unknown acceleration. Please note that we did not use all 4 forces in this equation. Why not? Just like in 2D motion, we separate our x's and our y's. They work independently. So in this case, the car is not accelerating in the y direction, so we don't have to worry about normal force and force of gravity. Those two are canceling each other out. There's no acceleration in y. But there is acceleration in x, so we only focus on those two, and that's how we end up with applied force minus friction force equals mass times acceleration. Okay, hopefully this is helpful. Now you guys are going to try some of these on your own.